Our next speaker is Alan Descoins. He is from Tryolabs. Tryolabs, the main office is a few blocks from here, beautiful in front of the sea. They are a friend of the house. So Alan holds a computer engineering degree and has more than 9 years of experience doing consultancy for companies in the Silicon Valley, mostly focused on developing robust backends, scalable infrastructures, and machine learning. So please give a round of applause to Alan.
All right, can you hear me now? Yes. Okay, very excited to be here. Bear with me, this is gonna be quick. It's just a 15-minute talk. So we're Tryolabs, as they were saying, we are an AI consultancy company. We have been born here in Uruguay, born and raised actually, although most of our work has been for the US clients. We don't only focus on the research, but also do production applications. So we are super excited to be here, and we're gonna start. You know, this field is moving fast, so we're gonna start by sharing some very interesting news. Okay, so every time I read some of these, I have a little secret I will tell you that I use not to feel very scared about AI killing us all. So every time I read these, I substitute AI, any mention of AI, by matrix multiplication and gradient descent, and then imagine that in fancy press headlines, and we get something like Elon Musk's billion-dollar crusade to stop the matrix multiplication and gradient descent apocalypse. So I guess it sounds much more fun and less scary. But I actually lied to you. I'm not going to talk about news, even less this kind of news. We are unfortunately going to talk about something else. So during the past 10 years, we've done a lot of things. We do consultancy, so we see a lot. We have done computer vision. We have done NLP. We have done predictive analytics. And we also have some cool ongoing projects. But I don't have time to talk about all of that. I just have to pick some. So let's start with something that actually had a positive impact in the world, as we have seen in other talks in the conference. And no pun intended with Cho. This is actually about lions. No llamas this time. So we have helped conservationists using AI. So the African lion is an endangered species. That means that their population is declining. Okay, so over the last 20 years, and because of the increasing human population and their activities, the African lions have lost about 42% of their habitat. The consequence of this is that their populations are now increasingly fragmented. The lions roam over very vast areas, so they cover hundreds of miles, and it's very difficult for organizations to actually track them across their entire range. And as a consequence of this, their movements through Africa are very poorly understood. But we need to understand where they're going, because we need to actually understand their behavior to know them more as a species, and also to help preserve their lands. So there is a possibility to track them using invasive methods, like this GPS tracker, but they come with some difficulties. So the GPS trackers are expensive. You need to replace the batteries every 1 to 3 years. So somebody needs to actually go there and change that battery. I wouldn't want to go near that lion. And even worse, the device can only be applied when the animal is sedated. So also, unlike other kind of animals, maybe like cheetahs, leopards, the lions lack the distinctive patterns in their coats that would make identification super simple for conservationists. So we partnered with the Link Foundation in order to develop AI techniques that would help with the identification of lions from photos more easily. The Link Foundation has a database of around 420 lions that have been manually identified by conservationists. These have been tagged by humans. So how do they do this? How do you identify a lion? Turns out it's not very easy. There are two ways, sorry. One is using the face that can give you a few hints as of which line you're talking about. But the lions change their appearance over the lifetime. So as the lions are more kind of puppies, they grow the mane, and then they completely change their face. So it's very hard to accurately pinpoint to which individual we're talking about throughout their lifetime using only the face. But there are other tips that conservationists have, which is the whisker patterns in the lion's face. That actually stays more invariant throughout the lifetime. And it's what the conservationists use for having the most certainty that they are identifying the right individual. So we started developing a deep learning system that could help the conservationists tag lions from photos more easily. So basically, we have a database of lions, and we are going to match pictures to individuals in this database so as to make their life easier. We are not aiming for a perfect identification, because that's very hard. But at least if they don't have to go over 400 lions, we will make their lives much easier and save a lot of time. So we built we tested several face ID models in lion faces, and we finally ended up with an implementation using a PyTorch and FastAI library. And this actually got about 85% top 5 accuracy, which was pretty good. But we know that their dataset has issues, in particular with intra-class variability, because they don't know that this was going to be ended up used for AI. So we are in talks with conservationists and giving them tips as to how to actually collect data for this to work even better. And this will help move research forward also. So there is another way of identifying lions, which is the whisker pattern. And we trained object detectors to locate all these spots in the photos taken by conservationists. So they use these really large lenses to take these photos from very far away. And after we have identified these spots, we can compare them to what they already have in their database. So they have all these canonical images of the whisker spots, and they go manually and try to align them and see how they match. So we kind of did the same, and we use some point registration algorithms in order to put one cloud over the other and then measure the distance in order to come with the lion that matches the best. So the results were not as great as a Face ID, but we know what the issues are, and we know that they can be greatly improved in the future. So AI-assisted facial and whisker recognitions for identifying lions more easily is in production today and helping happy lions. Yeah, we are using GANs in production. So after Ian's talk, you have seen that there are lots of applications. Most of them are actually for playing around. They're not actually in product. But we kind of managed to do this, and not for data augmentation, for a real customer-facing experience. So one of our clients is a luxury consignor based in San Francisco. This means that people actually send them items they wish to sell, for example, clothing or luxury items, a purse, or whatever. Then these items arrive to a warehouse where they are authenticated first. Then a photographer takes picture of the mannequin wearing the garment. Then they write a description of the item. They say, OK, this costs, I don't know, $200. And then that gets published in the website. So it looks kind of like this. But to get this pretty-looking photo that you see here, it's a very interesting process, because every single image that comes from the studio needs to be retouched. OK? So when the photographers take the picture, they have subtle issues with the alignment of the picture. Then they have to crop the vertical crop according to the length of the item. So it's different to if you're selling a T-shirt, you need to crop much higher than if you're selling a long dress. And the crop spot depends on the kind of item that you're selling. So they were actually sending many photos for manual retouching. We're talking about several thousand photos a week. So people went and did Photoshop over those. But we have the original images, we have the modified images, so the retouched images. So what can we learn from that? We want to use machine learning. So with point registration, again, as in the lion whiskers, we can put one image over the other. And that allows us to actually learn the rotation angle that needs to be performed for each original image. Besides, we can also learn the kind of cropping that we need to perform based on the item type. So as you have seen in here in these images, original human and computer, it's very difficult to tell the difference between human retouched and computer retouched. And only this step already can save a lot of time for our client. But mannequins also have joints and base. So they have joints in the shoulder that needs to be deleted, as you have seen in the original pictures. And also, they have the base, which they also remove via Photoshop. So this was a bit trickier. How could we effectively remove these things? So we experimented with some segmentation models and in painting, but the results were not great. In particular, like very subtle mistakes that the algorithm made, especially the in painting, were super easy to notice by the human eye. So we were wondering, like, what should we do about this? And somebody said, OK, why don't you try GANs? I mean, if we saw that they can turn a horse into a zebra, how could they not remove this joint? So we did exactly that. And we generated a data set based on the original and retouched images. So we took these patches around the affected areas, which we can identify pretty easily. And then use this as training example. So we have our class, our horse would be the item with the joint, and our zebra would be the item without the joint, and the same thing without the base. And we actually tried a cycle GAN, which is the same model that can turn actually the horse into the zebra. And we trained this, and the results were actually pretty good. So interestingly, as the model can turn horse into a zebra, it can also turn zebra into a horse. So it could actually take the jointless image and add the joint, which is fun. But we are, of course, not using that. So the results here, you can see the original human and computer retouched image. As you can see, again, we got pretty good results, especially when the item intersects with the joint. It was a very tricky case for in painting, because it kind of drew some of the paint for to the mannequin, and this kind of doesn't do it. We still are doing some other improvements for it to be even better. So yeah, we have GANs in production, and they are deployed as part of a large pipeline in GCP. We also work with machine learning edge devices, which you can see in our booth. I don't know if everyone has been there, but we got some post-estimation demos that are running on very, very tiny devices that are used for edge inference. We are using Google Coral. We have the Google Coral dev kit. We have NVIDIA Jetson Nano. And we have AWS Deep Lens camera. So yeah, we have done a lot of things. We have many ongoing projects regarding computer vision, NLP, predictive analytics, search and recommendations, description from images. We have a lot of things. But I'm not going to talk about our projects anymore. I'm going to talk about our most valuable asset, which is not our clients and not our projects. It's actually our team. We are now more than 50 people. And trust me when I say these people are super smart. We have a very diverse team. We have computer engineers, electrical engineers, industrial engineers, economists, marine biologists, yes, biophysicists. I'm still trying to figure out what that guy does, linguists, self-taught people, students, and we are welcoming even more diversity. So a little bit about other things we have done and our culture. We organize guided lectures in order to share knowledge of scientific papers. As we have seen a lot of knowledge in this conference, we have already read some of the papers in the team. We have hosted several international talks and workshops on AI-related topics throughout the world, and we also routinely organize meetups locally. So if you want to present something, just come to us. We can talk about the space. We are also hosting lately the R group meetups, hopefully trying to convince them that Python is better. We have won international awards, such as the Allianz GI Hackathon, in which we competed against other companies in NLP. This was done in Hong Kong, and we won thanks to Google BERT, so thank you, people from Google. We have organized the Python workshop for Anima high school students in an effort to foster technology in young minds. So this was a voluntary effort from our team. And also, speaking about that, our female team has participated in several initiatives, like Techi por el Día, which fosters the inclusion of young girls in technology. And many young girls got very excited about Tech and that robot that we had there. So dinosaurs are a very big part of Tryolabs culture, which you have seen if you tasted some of our cookies in our booth. And we have made them travel through the world very frequently. We have this kind of meme with the team, and we have a giant one in our office. So it's not all about lions or llamas for us. And last but not least, we did something that many thought was impossible. So how can the lay person here be interested and know about AI? So we thought about that, and after some brainstorming, like what could be the most Uruguayan thing that we have? So we have Giulia Varela, the greatest football player who ever lived and world champion in 1950. Sorry for the people in Brazil. We also have mate, which everybody knows. And we also have bizcochos, which is like our local version of donuts, so to speak. Yeah, we facturas for the Argentinos. I don't know how to say in Portuguese. But yeah, so these are the most Uruguayan things that we can think of. You can probably throw in some asado in there, some meat, barbecue. But yeah, we go one thing at a time. Sorry, Obdulio, we're coming for you, but we decided to focus on bizcochos first. So this is a picture of somebody having some tasty bizcochos in our office. You can see the nice view. But the most interesting thing is that if you zoom in here, you will see that we have a machine learning quiz. And this is actually what you can get if you go to Panaderia Panes, which is right next to this building. So if you're an engineering student, you already have seen these. And hopefully many people will get interested in machine learning. Like we got messages from everybody who has seen this campaign. And every Friday, we are giving away 1 kilogram of bizcochos for people who can answer this question. I guess some of you might know the answer, maybe. So in a nutshell, we like to work on challenging problems. We like to continually learn from each other. And we like to have fun in the process. And speaking about fun, as you mostly probably know, we are organizing the unofficial Khipu after party for tomorrow. So if you want to go there and you registered, so you come by our booth tomorrow, so you'll get the bracelet, and it's right next to this building in Facultad. And thank you very much. You can follow our blog where we post interesting technical stuff, Twitter, and get cookies in our booth. So thank you very much. We got messages from everybody who has seen this campaign. And every Friday, we are giving a...
All right, so our last talk is by Giulia Pagallo. She's a senior manager at Apple. She has a bachelor's degree in mathematics and a master's degree in computer science from the University of Central Venezuela. She received her PhD in computer science from the University of California, Santa Cruz. Giulia worked in the academia before she joined Apple. At Apple, Giulia has worked on handwritten recognition, intelligent assistance, and OCR. Recently, she is focusing on NLP and over 30 publications and patents. And Giulia will also be one of our panelists in the Women in AI event. So please welcome Giulia.
¿Aló? ¿Aló, aló? Buenas tardes, mi nombre es Giulia Pagallo. Estoy encantada de estar con ustedes en Khipu AI en Montevideo. Ha sido demasiado largo el tiempo que no he estado en Sudamérica. That's all my Spanish for today. So let's get started. I don't see my slides. Can I get the slides? Is there anything that I need to do here? There you go. All right, so let's get started. So my interest has been, as Pablo mentioned, in really using machine learning algorithms to help people communicate. And today I'm going to showcase a recent project that we worked on called QuickPath. Some of you may already be familiar, but as I go through, I highlight what that name means. Let me make sure that this is, there is something else missing here. No? Can I do it this way? All right, thank you. So when we plan a new machine learning feature for our systems, we have to think about 3 challenges. First, we want to create solutions that work for all types of users. Second, we want to acquire data in a privacy-preserving way. And third, we need to make sure that the solutions that we develop work in real time, so response to the user actions in the time that the user expects a response. So let me tell you how we face those challenges and how those challenges shape our decisions, both in terms of the modeling strategy for the algorithm that we chose, as well as the data collection strategy. So for QuickPath, if you're not familiar with, here is an example. The user can move their finger from a key to a key in order to enter a word. In this case, I'm showing you the case of the Spanish keyboard. But we don't only develop the solutions for Spanish, we develop it for many more languages, and here is an example for Chinese, where users are accustomed to enter many words in a single type session, and therefore we support many words in a single swipe session. Because of the diversity that we expect between the path, before we go there. So in order to deploy a successful solution, we really had requirements in terms of accuracy, responsiveness, and memory, and this footprint usage. And in these slides, I show you what that means in terms of QuickPath. So we want the system to respond as soon as the user is done pathing. We wanted the system to be accurate and at the same time consume very little memory and this footprint. Because of that, in order to really balance the accuracy and performance requirements, we decided to use a fairly shallow neural network architecture that is depicted in this slide. So in the architecture, the input to the neural network is a sequence of points from the path, which will get embedded into a multi-dimensional vector through a custom embedding, which is the input at a two-layer bidirectional SSTM, which generates character sequences that are then converted into word list by a CTC decoder. I don't have time to go into the details, but I'm more than happy to talk to you more about the different algorithms. But in the previous talk, you got exposed to what the LSTM's models are recurrent models. And the LSTM models, the reason why we use it in this case, for example, is because they are very good at temporal problems. So there is a signal that is in time, as opposed to the CNN models that are used in the image space. Now, as you know, to train neural models, you need a large volume of data, and especially you need representative and good data in order to create high-quality models. And so in the case of QuickPath, we wanted to make sure that the data that we trained the models was really representative of the type of data that the models were going to encounter in the wild. So we wanted the models to work equally well for male, female, for young people, older people, for people that are experienced pathing and novice and never used the feature. So we had a bunch of parameters that we really need to consider when designing our data acquisition strategy. And so we use 2 approaches. One, we collected data from paid participants, so the users really did not have privacy issues in this case. And the second one is we use a data augmentation strategy, which I'm going to talk to you in a second. So the main motivation for data augmentation is really to create data diversity to increase the accuracy and robustness of the model when they are deployed in the wild. But there are other benefits. One of them is, which we use frequently, is we start with data, synthetic data, in creating an experiment with models. As you've seen in previous presentation, there is a wide variety of potential models that you can choose from. And so by using synthetic data, you can start experimenting even before you have data available from the actual domain. The second one is that data acquisition is very lengthy and costly process. So we wanted to see if by using data augmentation strategies, we could reduce time and cost. So how do we go about doing data generation for QuickPath? Well, you can think of a very simple algorithm. Let's say you want to create a path for the word at. You can think about choosing the keys A and T, putting a Gaussian distribution around them, and then sampling 2 points and joining them with a cubic spline. Okay? So that generates path, and we actually did that. But when we look at the path, and the top path is path for the word anybody from a user, and the bottom one is one generated by this rule-based approach, you notice a few things. One is the rule-based path does not have all of the artifacts that the user path have. It doesn't have overshoots, undershoot, and excursions from keys. And also looks very stiff. So then we thought, well, how can we generate paths that look more realistic? And the way we thought about the process of the problem is as a style transfer using GANs, which has been used successfully in the image domain. So what makes a path, a synthetic path, look realistic? So first of all, as I mentioned before, it has to have the same kind of artifacts the user path have: undershoot, overshoot, excursions. It also is important that the path generated by the algorithm really is a path that corresponds to the target word. And finally, you also want a system where when you inject actual user path, they are minimally disturbed so you don't pollute your data set. So with that, we built a system that is a multitask GAN, and I'm going to walk you through the different elements of this system. So you all heard about Ian, about GAN systems, so I'm going to just give you a very quick overview. So the first part of the system, which is the generator and this discriminator, the generator is responsible for essentially creating paths that look user-like by transferring the style, by taking as input the rule-based path and transferring user-like style to them. The generator wants to be as good as possible to fool the discriminator so the discriminator cannot tell apart a user path and a synthetic path. If you just do that, well, we observe that our path may not correspond to the intended word. So that's why we went to the multitask solution, and we impose constraints to the generation of the path by requesting that the path also had to be a valid path for the intended word, and that the path, when it was reconstructed from a user path, would not deviate too much. And so by combining these different losses, we actually got the following. So the bottom path is, for the word anybody, and you can look at the Y key, and you see that there is overshoot, which is one of the artifacts that we were looking at. If you look at the key D, you see that there is excursion. However, we still see a problem in the middle where our paths are still more wobbly than we would like. And that's an area of research for us to understand how to improve them. So now, this is a visual inspection of the path. How did we go about validating the quality of the GAN algorithm? And we used the downstream approach that Ian was mentioned this morning. Essentially, we generated the data using a GAN, added to our training data, and look and evaluating how the new model was doing on the same test set. So let me show you some results. So in this graph, I wanted to emphasize are the accuracy results of the path recognition. There is no language modeling on top of that. And the language model is an important component of the system. But in terms of, for this talk, I'm focusing on path recognition accuracies. So as expected, this graph shows two models, one trained with 1 million user path and one trained with 2 million user path. The model trained with the 2 million user path is better. Now, what happens if we keep the amount of data, the training data fixed, but we change the mix? And so if we created a training model that has 1 million user path and 1 million rule-based path, the synthetic path, the simple ones, things do not get better. And our hypothesis is because the rule-based path really kind of are not good at capturing the nature of the user path. Now, what happens if we do 1 million user plus 1 million GAN, and we get about the same accuracy at 2 million users? So this is telling us that in the future, for this type of problem, we could collect less data, train a GAN model, and increase the accuracy. The other results that I'm going to show you that for us is that as we increase the volume, the amount of training of GAN-generated data to train the model, the accuracy got better. So this shows from 2 million users, the blue bar, to 2 million users plus 1 million GAN, 2 million users plus 2 million GAN, 2 million users plus 10 million GAN, and that's when we stopped. I don't know if that it will continue to grow or plateau, but we had to ship, so we stopped there. So in summary, what I wanted to mention is there is a lot of, we talked a lot about good data, training data. So I wanted to bring to your attention the fact that data augmentation is a very powerful technique. It not only allows you to have collect less user data and augment it in a different way, but it also allows you to do a lot of experimentation before you have any user data. At least that was our case with QuickPath. So data augmentation, synthetic data augmentation, is a very interesting technique to have in your toolkit of machine learning algorithms. And with that, I want to say thank you. Is there time for questions? I don't know if there is no time for questions. I'm going to be around the rest of the week. You can find me and the rest of the Apple team at the Apple booth.
You have 2 minutes.
2 minutes. All right, short question or short answer. The milk is out of place? All right, now it is. Thank you.
Hello? So I was wondering, in the first chart of the results that you showed, how the variance on the accuracy actually behaved with the data augmentation, because maybe it got better or it got similar, but the variance got bigger or less.
Right. Because I've only had 15 minutes, I kept the results pretty high level. But yes, I think that there is real signal. And, oops, no. There is real signal here. And I forgot the exact numbers, but we calculated the confidence intervals to make sure that we're not hallucinating accuracy.
Thank you.
Very good. Thank you.